So in this lesson, we're going to be talking about gases, and in the entire chapter, we're going to be talking about gases. So we've got to discuss the kinetic molecular theory, which is 4 different statements and 4 different assumptions that we're going to make whenever we talk about gases. So the first one is that gases are a collection of particles that are constantly in motion. They are constantly moving. Secondly, is that we assume that there's no attraction or repulsion between these particles. So if they collide with one another, they're not going to stick to one another. They're going to bounce off each other just like pool balls do. Okay? 3, there's a lot of space between those particles compared to their actual size. So if you were to take a gas and compress it, the volume would decrease significantly because the volume between those gas molecules is so large. So you can compress gases very easily. And finally, the speed at which those particles move, it increases when you increase temperature, which makes sense because if you're going to give gas molecules energy, they're going to start moving faster. Okay? So one term we have to talk about when we're talking about gases is pressure. Okay? Now pressure, one term that we will be talking about is atmospheric pressure. And so that's the amount of pressure resulting from the air pushing down on us, because if you can imagine, the air above you is like a column, and it is a column which will push down on you because there's a large amount of gas above you. Now the interesting thing is if you are at a lower altitude, the pressure will be higher because there's more air above you pushing down on you. While if you're up in the mountains, the pressure will be less because there's literally less air pushing down on you. So that pressure, that pushing results in a number of different differences that result when you're in the mountains versus when you're at sea level, which we will discuss later on. Okay? So, pressure. We need to, now that we've talked about it qualitatively a little bit, right? The pressure is a force that's exerted over a specific area, so we're experiencing atmospheric pressure right now as you're watching this video. We need to give it units, of course. So, units of pressure include atmospheres, kilopascals, and millimeters of mercury. All right, so 1 atmosphere equals 101.3 kilopascals, and that equals 760 millimeters of mercury. So these are the most common units for pressure for gases that you'll see in this class. So let's convert. If I give you 1,277 millimeters of mercury, and I ask how many atmospheres that is, what you need to do is you're going to write your given, that I'm going to get out of millimeters of mercury by putting it on bottom. I'm going to get into atmospheres by putting it up top. Then I know that there's 1 atmosphere for every 760 millimeters of mercury. So what I'm going to do is I'm going to divide 1,277 by 760. I want 4 significant figures in my final answer. So my final answer will be 1.680 atmospheres. And that's all there is to converting between units of pressure.